I'm Zac Shenker. I work at Fastly, but today I'm going to be talking about some new features that Apple have recently announced as part of the HLS spec around content steering for multi-CDN use cases, and then also a separate spec they've recently announced, actually as part of the same presentation on interstitial content in HLS. So we'll start today talking a little bit about where the current landscape is with HLS around content steering and multi-CDN. I'll then go into what the new content steering spec introduces, how to use it, what's there. Then we'll switch gears and jump into the landscape for server-side ad insertion and stitching together different content in HLS as it stands today and approaches people use there. And then we'll jump into the new interstitial spec, how that operates and how you can use that and what benefits it starts to provide. And then finally, I'll talk a little bit about where all of this work is happening, where Apple are announcing things and how you can get involved in these conversations about what's coming next in HLS. So jumping into multi-CDN and content steering. So really today, there's a lot of, customers, there's, a lot of media companies out there that have a need for multi-CDN from a lot of different angles, be it certain CDNs are more performant in certain regions for redundancy and failover, or in the case of very large events, it can also be for scale reasons and distributing the load across multiple vendors. Today, multi-CDN and content steering isn't really a native sort of part of the HLS sort of spec or ecosystem. So there's been a number of different approaches that people have implemented to achieve some of this, both with kind of their pros and cons. I'll talk quickly about some of the most common ones here. So first, there's DNS-based content steering. So this is when you use your DNS provider, either as authoritative or as recursive, and you have your DNS provider be able to answer those DNS queries and steer different users to different CDNs. So it could be using various sets of performance data, RUM data, or QoE data or other data sets, but ultimately it's a DNS decision that's issued to tell the user which CDN to go to. In this case, you need all your CDNs to be able to handle the same host name and have TLS certs for those domains. And this is very easy to integrate in a lot of workflows, and it works pretty universally. So, I think from that perspective, a lot of companies have decided to go this path. And in general, it works pretty well, particularly if you have, short content and you don't need midstream switching and, you have a good enough data set to drive your decisions, it can work pretty well. The downside of it is not all clients or not all recursive resolvers really respect DNS TTLs correctly. So if you're running multi-hour long live events or longer form VOD, this can really be a solution where you can't necessarily force a user to switch very quickly. So a user may be stuck on a CDN path that's now having issues. The next alternative is doing this manifest-based, and there's a few options here. One is using redundant streams where you advertise the same rendition URL with all of the same attributes, the codec and bitrate and everything else, but you have URLs pointing to two different CDNs. This can work fairly well, but some clients and some players don't support this super well, or may not, may not select CDNs in the order that they're in manifest. So you can just lead into some unexpected behavior with this approach. There's also some approaches where you may do this on a per segment basis. So as there's a new segment to write into a live manifest, you'd swap out that segment. yeah, with the URL for a different CDN. Some of the downsides with this is, as part of the HLS spec, once you've advertised a URL, you can't easily, it's not in the spec to change a URL that's advertised, and it can cause some players to bail out of playback if you change some of the previous URLs. So that can mean that you have to maintain state for every user session as to what segments you've issued before. But that does allow you to switch on a per segment basis and have some reasonable level of control over that switching. And then finally, there's a number of implementations out there that do more client-based switching. So they integrate into the players themselves, and that gives you a lot of really fine-grained control. You have all the throughput estimation and data that the player has about video playback. In some cases, the players might go and probe the other CDNs to keep collecting some active measurements of other CDNs. But I think some of the real challenges here are really integrating this in a uniform way across a broad set of platforms. So now I'll jump into the new content steering spec that Apple recently announced. So today I'm going to focus on what is now the latest and current version as of today. That's version 1.2 B1. This is about the third version of the spec, and I'll talk a bit more about kind of the development process of this in a little bit. So this is really designed to be backwards compatible. You can serve out a master manifest that supports the spec that will still work with other HLS players. So this is designed with some of that in mind. And really the idea here is to provide a method for the clients to be able to frequently fetch from a remote server an ordered list of CDN selection, and then leave it up to the players to decide, in error conditions and failover, when it actually needs to work its way through the list. But the server can kind of drive the general sort of preferences of CDN selection, or can override and force by adding or removing CDNs from the list during the playback session. In this current version of the spec, all the CDNs that you want to use have to be specified in the master manifest. And part of this was also to allow you to use different token auth schemes for different CDNs. Apple have made it clear in the future they may add some flexibility to allow you to add additional CDNs during playback, but right now they all have to be specified in that master manifest at the start of your playback. So there's a few new pieces that the spec adds to HLS. The first piece is this #Extx content steering. And this really only has two attributes. The first is the server URI, which can be an absolute or relative URL to a remote server. It can also be a data URI, a base64 encoded data URI, so you can provide the payload, the content steering payload through this data URI as well. And then the only other attribute here is the pathway ID. So that specifies the default CDN, the default pathway selection that the player should use before it gets the first response from the steering server. Because the idea here is that the player can start loading segments immediately, and then concurrently make the request to the steering server, and then switch pathways if needed after that first request, so that you don't delay playback with this request to the steering server. So there's also then a few additional query parameters that the client's expected to or could be adding to the request to the steering server on each request that it makes. The first is this, and they're all using the _HLS_ prefixes as Apple introduced with the LLHLS spec. The first is the HLS pathway. So that's the ID of the current pathway or current CDN selection that the client was using when it made that particular request to the steering server. And then the other attribute is the the HLS is the throughput. So this is the sort of bandwidth estimation throughput value that the player last measured. And this is sort of intended to be provided to the steering server just to provide a little bit of telemetry back, to indicate how the player is doing on that current CDN. This is an extensive sort of QoE data, so I think we'll see over time how much people will use this on the server side versus using other data sets, or maybe it just adds into any other data sets that you use for your CDN selection. It's recommended that you exclude particularly the throughput, and possibly the pathway from your CDN cache keys. If you do want to cache, steering server responses, some of that may depend on how you build out your steering server application and what you can handle there. At large scale, it may make sense within particular ASNs or regions or areas where you have a pretty good confidence that some users are going to get the same CDN selection. You could reduce load on your steering server by putting a CDN in front. So the steering manifest itself, so it's a JSON response. It was asked, hey, well, why is this JSON when most other things in HLS land are not? This isn't. There are some other cases where JSON's used, and I think it was just kind of seen as JSON is pretty standard for APIs and web servers to be returning. So that's what Apple decided on here. The first field is the version flag, so that's always 1 in this case. The next attribute is TTL, so this tells the client how long this particular steering server response should be valid for. So after that TTL expires, the client's going to make another request to the steering server. This is really designed so that the if the steering server is getting overloaded with a lot of requests, it can start to return longer TTLs to delay some clients, or if you're starting to see conditions get a little choppier and you need an ability to start switching quicker and forcing changes quicker, you could start to lower that TTL to get clients to refresh more often. It's also possible to modify the the URI or URL for the next request that the client makes for the streaming server, so you can modify that each time you return a steering response. And then the final property here is, and probably the most important overall, is the pathway priority list. So this is just an ordered array of those pathway IDs. So with that, let me jump into an example. So here you can see this has a 300-second, a 5-minute TTL. It's got a URI to the steering server. That is optional, so if you're not changing it, you don't need to provide that. And then you can see here there's 2 CDNs, and they're in the order CDNA and CDNB. So then, how do you then use this? How do you actually indicate where all the different streams are coming from? So as part of this new spec, it's adding an optional additional parameter, and this is kind of what makes it a little bit more backwards compatible, is clients that don't know about the steering server tag and now this pathway ID operator can just ignore those and treat this as a normal redundant stream. So this uses a similar approach as I talked before about the redundant streams that were already in the HLS spec, where you can specify these extra tags with the same renditions, but pointing to different CDNs. And shout out and thanks to Phil Clough at Mux for coming up with this idea of repurposing the redundant streams feature for content steering. This wasn't part of the initial spec that Apple announced. In this case, your rendition manifest URIs can be either absolute or relative. It's very likely that your CDN that is not your default path, you will probably want to be absolute URLs, so that you can be sure that they land in the right places. Otherwise, if it's relative URLs, you could run into some issues there. So then a big part of sort of switching into this approach of modeling after redundant streams was really to allow different token and different sets of query parameters to be added for each of those CDNs that you have in the stream. The master manifest token, obviously, that has to be valid for whichever request, whichever CDN is serving a master manifest, but then you can include tokens for the renditions across different CDNs with different token schemes. So finally, let's actually show an example of what all of this looks like. So you can see here at the top, there's that Extx content steering tag specifying the steering server. In this case, the default pathway would be CDNA. And then you can see here that we have two renditions. We have a low and a high. And you can see that they're at the top here, we have the low and high renditions with the pathway ID for CDNA. And then down the bottom here, we have the same renditions, a low and high, and you can see, they have the same bandwidth, the same codecs, but now pointing to a second CDN. So these, can then have their own URLs, own sets of query parameters. They don't have to match. So that was content steering. I'll now quickly jump into the SSAI, and then we'll go into the interstitial spec. So first, SSAI today. One of the most common ways people are really doing this is with the Extx discontinuity tag. This really indicates to the players that there's an upcoming change in the video stream in some way in the next segment in the stream. This is a tag that'll be in your rendition manifest. And generally this will cause the player to reset the decoders and be ready for the stream to potentially look a little different in the next segment from what it's had to play so far. So this is a quick example here where, say, that this could sort of be demoing a pre-roll sort of example in HLS. So we've got a stream, it's got two segments here. Say these are our pre-roll ads. After that, we've got a discontinuity, and then it switches to my program content, my movie content. In this case, like you could also have the ads and the content being served from totally different domains, and it's pretty common here that that you have ads coming from one place and content coming from somewhere else. So some of the challenges with this existing approach, not all players necessarily handle discontinuity tags in the same way. Some don't always fully reset decoders, so streams aren't encoded correctly. That can lead to some issues across playback going into or out of ad content. So really, as part of that, you still need a whole workflow to prepare your ad content in a very similar way to your content. If you have significant codec changes or huge bitrate swings or other big changes in the stream, that can lead to some playback challenges between the ad and the program content. In this case as well, ads can only be placed at these segment boundaries because you can only insert the discontinuities at segment boundaries. What that leads to in some cases for VOD workflows is people do something commonly known as preconditioning, where if they know where the ad break needs to go and it's within a segment, they'll take that segment, split it up on the closest keyframe to the ad break so that they can insert a discontinuity tag in between those now two segments instead of one. For VOD workflows, because players never go and re-request any of the manifest, the master or the rendition manifest, all of your ads have to be decided on. You have to have segment URLs. So in some cases, if you have long content, if you have multi-hour long content, and there could be, dozens of ads or ad breaks during that time, it can mean that you have to go to your ad server and go and resolve all these ad breaks and do all of that work before you can actually deliver the manifest. That can significantly slow down and delay the time that it takes for player starts of your video. And then finally, in some cases, there's some need for client code and SDKs. That could be for things like firing client-side ad tracking and ad beacons. Could be for limiting like seek behavior, or for like disabling player controls while the player's playing an ad. None of those are natively supported in HLS today. So finally, we'll get into this new interstitial spec. So the aim here is to make it easier to deploy ad-supported content. This provides both a server and a client-driven approach. So this makes it easier, if you're an iOS developer and you want to do this all in the app, it starts to add some more native abilities for you to do that, and it makes it a lot easier from the server side. So it no longer relies on discontinuity tags. It enables late binding and rebinding of both individual ads and ad pods. You get more flexibility as to where you place the ads, more flexibility around when you advertise them, particularly in live cases. You get more control over being able to change ads later and things like that. And then also this natively supports some of those navigation restrictions and limiting controls and seeking, including on AirPlay, at least with more modern AirPlay receivers, and best effort on some older AirPlay devices. This, unlike the content steering spec, really is a lot more limited in backwards compatibility. This you could potentially still it's more challenging, and that was not really as much of a design goal in this use case. So you may still need to for some time support both the discontinuity workflow and an interstitial workflow. Today I'm going to focus really just on the server directed use case and not touch on the client, but I'll point you to where you can go and find the specs and the documentation on that side. So to signal interstitials, it uses Extx date range tags. And a lot of this specification now really starts to rely on having program date times tags within your stream. Within these date range tags, they have to specify the class of com.apple.hls.interstitial to specify that what you're providing is an interstitial. There's then two ways that you can signal where your interstitial is. The first is with xasset URI, and in that case, you're specifying there's just a single interstitial to go and play. These URIs really are just standard HLS URL. So they can be an entire other master manifest URL that you're pointing to go and tell the player, to go and load and play this entirely separate stream as your ad, as your interstitial content. The other option here, which could be used in cases, say, where you have like an ad pod of multiple individual ads to play, is this xasset URL. So you just specify here a JSON encoded array of those different URIs that you want to play as part of this asset list. The next value here is the xresume offset. So generally, and what this really does is specifies after it's finished playing this interstitial, where should it resume from? In the VOD case, you generally would set this to 0, which would tell the player resume, immediately where you paused or stopped from before you went into the interstitial. If you don't specify this tag, and this is an optional tag, the player will use the amount of time that it was playing the interstitial for, and use that as the amount of time to skip ahead in the underlying sort of program content. This is really designed for live streaming use cases where during that ad break, the live stream might just have black or might have slate or something like that in it. So you want to make sure you resume, at the right time after that period of ad playback. And then finally, there's the X playout limit. So you can also specify in here a maximum time for interstitial. So if there's some remote server that's actually generating these other URLs to play for like your ads or ad break, you can also specify as part of this tag, how long you want to be allowed to play for before the player will force it back to your program content. There's also a few additional options that handle, how it limits seeking behavior and things and navigation restrictions that I won't go into today. So finally, here's an example. So we have a stream here. You can see at the top here we have a Extx program datetime tag. So this has 21:55:40 as the program datetime at the top of the stream here, and then we've got these three segments. Previously with discontinuities, you'd only be able to insert your ad breaks at the segment boundaries. In this case here, you can actually see that the start date attribute that's specified is at 44 seconds here, and the start of the stream was at 40. So we're actually going to play this particular ad at 4 seconds into the first segment here. So the player would, pause the main content, load the interstitial, go and play that out. And then in this case, we have a resume offset of 0. So we'd resume playback at that 4 seconds in the program content. So that's really showing something here, that really wasn't possible with just discontinuities. And there's, a huge benefit here to having these, these ad and interstitial streams now being totally separate, master manifest. They can switch codecs, they can be different bit rates, they can be different sets of renditions. So you have a lot more flexibility than you did, and you don't have to match everything to your program content as much as you've had to in the past. Finally, I want to talk about where all of this work has been happening in the community. So if you're not on it, there's under the IETF now, there's this HLS interest mailing list. This is really where Apple now are posting all of these announcements of new specs. They announced that they were going to hold a presentation. All the presentations, all the specifications they've released have been going out on this mailing list generally before they've been posted on any websites or anywhere else. There's been a lot of discussion and conversation and updates to the spec that have all gone out through this mailing list. So it's a great place to be on if you're interested in staying up to date with what's happening in HLS. And finally, one thing I want to call out here was, there was a great opportunity after the first version of this content steering spec for some different groups of companies across the industry, and then through the SVA as well, to really go through what Apple were initially presenting, which didn't present any easy ways to support token auth across different CDNs, and then the SVA and various groups, companies came up with this redundant streams based approach, submitted the proposal back to Apple, and that was accepted as this latest version of the content steering spec. So it's great to see that Apple are really listening to feedback from the community. And that's everything I have today. Happy to take any questions that anyone has.
That's great, Zac. Sounds like Rob's going to be very busy.
Yes, it seems like there will definitely be a lot to add into HLS. I mean, hopefully it being based, interstitials being based on, multiple, the existing redundant streams might make it a little easier. I mean, Apple have said they're going to be using a sort of 2-player system to be able to sort of enable more seamless switching between the content and the interstitials. So I think it'll be interesting to see how, some web players and mobile devices, that can't support sort of two-tag, sort of two-player systems handle some of this.
Well, thank you so much, Zac. That was awesome.